A warm evening to all the students and viewers. Welcoming you all to the live session conducted by Ace Engineering College on the topic Analysis of Determinate Trusses. This topic all the students will study either in Structural Analysis 1 or in Strength of Materials 2 according to your university. This subject is often perceived to be difficult as it predominantly consists of numericals. But with thorough understanding and right application of the concepts, problems can be solved very effectively. I am G. Alekhya, Assistant Professor, Department of Civil Engineering, Ace Engineering College. Today I am here to discuss very few important concepts and also to show the representation of the numericals while solving so as to facilitate students to perform well in their university examinations. So today coming to our topic, Analysis of Determinate Trusses. What is a truss basically? A truss is a pin-jointed structure which is having only axial loads. A truss can carry only axial loads. So if you see the figure, all the green dots you can see here, right? These are called as joints. And the joints are assumed to be pin-jointed. And if you see the truss, this is a simply supported truss. This is the basic structure of a truss. Coming to the next topic, types of trusses. In many universities, they will ask you this question for very short answer. They generally ask you to classify types of truss based on the structural stability or to define a perfect and an imperfect truss. So there are many trusses like king post truss, queen post truss, Warren truss, Pratt truss, etc. But those are all not needed as far as the university pattern of question is restricted to, because they will only mention about perfect and imperfect truss. So let's see what are the types of trusses based on structural stability. One is a perfect truss and the other one is an imperfect truss. What is a perfect truss? A truss which satisfies m equals to 2j minus r. Which satisfies m equals to 2j minus r equation. That particular truss is called as a perfect truss, where m equals to number of members, j equals to number of joints, and r equals to number of reactions. A truss that satisfies this equation of m equals to 2j minus r is called as a perfect truss. Then what is an imperfect truss? Obviously, the truss which is not satisfying m equals to 2j minus r. The truss which is not satisfying this equation is called as an imperfect truss. That means there may be excess members or less members compared to the required members. So generally, an imperfect truss may be a deficient truss or a redundant truss. So what is a deficient truss and what is a redundant truss? By the name itself you can see a deficient. Deficient means deficiency. When a truss is having less members than the required members, that truss is called as a deficient truss. Mathematically, we can write it as m less than 2j minus r. M less than 2j minus r. So what is a redundant truss? A truss in which members are than the required members, that truss is called as a redundant truss. A truss in which there are more members than required. So mathematically we can write it as number of members greater than 2j minus r. So just by knowing what is a perfect truss and an imperfect truss, you can attempt your very short answer question in many universities. Now coming to the next topic, assumptions in truss analysis. In many universities they will give directly to write the assumptions in truss analysis, either in very short answer question or in short answer questions. So there are 4 assumptions clearly. If you just write the points, you will get marks easily. So let's see what are the 4 assumptions. First assumption is the load will act only at the joint. The load will act only at the joint. For example, if you consider a truss, the load will act only at the joints. So here either at this point or this point, whatever is highlighted in the figure, only at that point the load will be acting. This is our first assumption. Then coming to the second assumption, all the members of a truss are perfectly straight. So whatever the direction of the truss members may be, whether it is horizontal direction or vertical direction or an inclined direction, irrespective of the inclination, all the members should be perfectly straight. Assumption. The joints in the trusses are assumed to be frictionless hinges. Coming to the final assumption, self-weight of the truss members is neglected. Why? Because if you see a truss, any component of the truss will be made of a material only. The material will have some weight. So that self-weight of the material will be subjected, the member will be subjected throughout the load, throughout its cross section. So in that case, if this is the case, what will happen? You all know that when a member is loaded with uniformly distributed load, it may undergo shear force and bending moment. Hence, that is the reason why we are considering self-weight of the member to be neglected. So these are the 4 assumptions which when written you will score marks effectively. Then coming to the next topic, sign convention. Of course, this is not asked in any of the university exam questions, but to solve the long answer question, that is nothing but a numerical. You have to know the sign convention. Without knowing the sign convention, we cannot solve the problem. So there are 2 sign conventions generally, because all the members in a truss only carry the axial load. Axial load can be of tension or else a compression. So when do we say the member is subjected to tension, or when do we say that to a compression? So for that, let me consider a truss which is joined at the joints. So when the force in the member is trying to pull the joint or acting away from the joint, then we'll say that the member is subjected to tension. When a force in the member is acting away from the joint or pulling the joint, you can see this is a joint, right? Pulling the joint or acting away from the joint, that is called as tension. Then what is compression? Yes, when a force in the member is trying to push the joint or acting towards the joint that member is said to be subjected to compression. That member is said to be subjected to compression. Just remember two things. Pulling of the joint is tension and pushing of the joint is compression. If you remember these two clearly, numericals can be solved without any doubt. Coming to next topic. Rules to identify members carrying zero forces. So there are three rules basically. First rule is rule number 1. When any member is existing as a single member, then the force in that member must be zero, right? There will not be any single member acting in the nature. So for example, if you take this member, that is a single member, right? So obviously if this is A and B, the force in AB must be zero. It should be zero. Then rule number 2. When two members are meeting at a joint and they are not in the same line. When two members are meeting at a joint and they are not in the same line. Then, for example, consider this as AB and C. Then, in this case, the force in the member AB must be equals to 0 as well as the force in the member AC also must be equal to 0. Whenever two members acting at a joint are not in the same line, the force in each member must be 0. Then coming to rule number 3. When three members are acting at a joint, out of which two members are acting in the same line, then the force in the third member must be 0. For example, I am considering this truss ABCD. These are the three members acting at a joint. In this case, this is FAB, this is FBC, and this is FBD. The force in FBD must be 0 because it is not lying in the same line of AB and BC. Wherever you know, now the force in the member AB must be equals to force in the member BC, but opposite in direction. Both the force in the members AB and BC are equal but opposite in direction. So these are the three rules which, when remembered, can be directly applied to the questions, long answer questions in the university examination, as well as these are the few shortcuts you can use them in GATE and your ESE examinations. Now, going to method of analysis. The main topic of our session is method of analysis. So there are three types of methods available. One is method of joints, second one is method of sections, third one is tension coefficient method. These are the three methods available to analyze a determinate truss. In today's session, we are going to see a numerical and learn about method of joints. Before going to solve a numerical, let us discuss few points that are very important before solving the numerical. So what are those points? The main objective of the analysis of truss is to determine forces in each and every member of a truss. To determine forces in each and every member of a truss. So to determine each and every member of a truss, force in each and every member of a truss, we have to calculate the reactions, right? So first step will be calculation of reactions using the available equilibrium equations. So what are the available equilibrium equations, as you all know? Sigma Fv equals to 0. Sigma Fh equals to 0. Sigma m equals to 0. These are the three available equations using which will determine the support reactions. Some may say that sigma Fx equals 0, sigma Fy equals to 0 and sigma m equals to 0. Anything is okay. Now, how to determine forces? So to determine forces, we'll use the method which is there in its name only. It is method of joints, right? So each and every joint is considered separately and free body diagram is drawn representing all the forces in the members meeting at that particular joint. Each and every joint is considered and free body diagram of all the forces in the members meeting at that joint is represented. Then only we will continue to determine the forces. Now, if you consider a truss, there are many joints, right? This is one joint, this is second joint, this is third joint, this is fourth joint, fifth joint, sixth joint and seventh joint. There are these many number of joints. So with which joint will we start our problem with? Yeah, for that only I am going to tell you one rule. Just remember, whenever you are going to select a joint to start the problem with, you have to select a joint which is not having more than 2 number of unknown forces. Why only 2 number of unknown forces? Why can't we go for a joint that is having 3 unknowns or 4 unknowns or many more? Why? Because here we are calculating member forces by considering joints. So at every joint, the members which are connecting can carry only axial loads. So whenever axial load is only being carried in the joint, we can apply only 2 equilibrium conditions out of the 3 available equilibrium conditions. Out of the 3 equilibrium conditions available. So what are those 2? We can only use sigma F sigma Fv equals to 0 and sigma Fh equals to 0. We can use only 2 equilibrium equations. So we all know mathematics, right? With 2 available equations, we can only solve 2 unknowns. With 2 equations, we cannot solve 3 unknowns or 4 unknowns. We can only solve 2 unknowns, right? That is the reason why whenever you are going to select a joint, you have to remember a point in your mind that the maximum number of unknowns at that joint must be 2. It should not exceed 2. So these are the few points you have to remember while carrying out the method of joints. Now let us jump into the numerical. So what is the numerical? Analyze the given truss and obtain the forces in the members using method of joints. They are asking you to determine the forces in members using method of joints. And the truss given is here. So let me just recall the assumptions to you. You can see the loads here are acting only at B. B is also a joint, right? So the loads acting in a truss will be only acting at the joints. Similarly, there are vertical members, there are horizontal members, and there are members. Whatever may be the direction or the inclination of the members, the member must be perfectly straight. Right? So, before going into the problem, let me just give you the sign convention. This is the sign convention, right? Now I am considering upward acting force and the force that is acting right side as positive, and the force which is acting towards the left side and the downward acting force as negative. There is no rule that you have to follow this sign convention only. You can follow vice versa also. You can take that as negative and take this as positive. But just remember one thing. Whatever sign convention you have choose to follow, you have to consider it, or you have to stay on that sign convention throughout the problem. You should not change the sign convention in the middle of the problem according to your wish. Any one sign convention is only to be followed throughout the problem. So we all know that at A there is a hinged support, right? So at hinged support there will be two reactions. One is a vertical reaction RA and second one is a horizontal reaction HA. Similarly at D there is a roller support. At a roller support it is a horizontal roller. So we will have only one reaction at D. That reaction is RD. So what is our first step? Our first step is to calculate the reactions. Calculate reactions at support. So, first let us consider equilibrium equations. Using equilibrium equations only we are going to solve, right? So, first one is sigma FH equals to 0. If I want to apply this, I have to see how many horizontal forces are there. Only two horizontal forces are there. One is HA and the other one is 20 kilonewtons. 20 kilonewtons is acting towards the right. So the right side force is assumed to be positive, right? So 20 kilonewtons, and HA is acting towards the left. The left acting force is assumed to be negative. So minus HA equals to 0. From this equation we can write as the force, the reaction, horizontal reaction at A, HA is equals to 20 kilonewtons. Next, the other equilibrium equation we can use is sigma FV equals to 0. So, there are RA and RD reactions at the support. Those are acting upward, right, towards the up direction. So, that is termed to be positive. So, RA plus RD, and there is another load here in the vertical direction, that is 30 kilonewtons. It is a downward acting load. So, minus, right? So, directly I am writing as RA plus RD is equals to 30 kilonewtons. Let this equation be 1. There are two unknowns and one equation available. We cannot solve it, right? So consider the third equilibrium equation available, that is sigma m equals to 0. We can either take moment at A equals to 0 or moment at D equals to 0. Now I am considering sigma ma equals to 0. So if I consider this, at A we cannot have moment due to RA or HA, right? So at A, what are the moments we are getting? We are getting moment due to RD. Due to RD, if you see the moment of the pen here, it is an anti-clockwise moment, and the moment is equals to RD into the distance, that is RD into 15. Then if you see 30 kilonewtons, 30 kilonewton load is creating a clockwise movement. As we have considered anti-clockwise movement positive, we have to take it as negative, clockwise movement as negative. So minus 30 into what is the distance between 30 kilonewtons and the point A? It is 5. Similarly, due to 20 kilonewtons also we are getting a clockwise movement. So minus 20 into horizontal load into vertical distance, 4 equals to 0. That implies 15 RD is equals to 150 plus 80. From this we can write RD is equals to 15.33 kilonewtons. 15.33 kilonewtons. Now we have already got RD. How to determine RA now? From equation 1. From equation 1. What will be RA? RA will be 30 minus 15.33. So RA is equals to 14.67 kilonewtons. RA is equals to 14.67 kilonewtons and RD equals to 15.33, where HA equals to 20 kilonewtons. Then what else should be done here? We all can see there are inclined members here, right? So we have to calculate the inclination theta. So here it is theta. This will be theta. This will be theta. This will be theta. This will be theta. So we have to calculate this. Obviously this also will be theta, right? So second step is to calculate just a second. Calculate theta. So how to calculate theta? If you consider from triangle ABE, you can write tan theta is equals to 4 by 5, right? Tan theta equals to vertical side divided by horizontal side. So that equals to theta equals to tan inverse 4 by 5. From this we can write theta as 38.65. 38.65 degrees. So we have calculated the theta, we have calculated the reactions. So after that what we have to do? The last step pending is we have to calculate members in all the forces in the members using method of joins. So step 3 is calculate forces in members by method of joins. Calculate forces in members by method of joint. So before blindly starting the problem at considering any joint, we have 3 rules, right? So let us first check whether we can apply any of the member available. As you can see, how many members are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 members. 9 members are there. So at A, there are 2 members meeting at A, but they are not in the same line. But the force in those members will not be equals to 0. Why? Because there is a reaction Ra here. Ra equals to 14.67 kilonewtons, where Ha equals to 20 kilonewtons and Rd equals to 15.33 kilonewtons. Right? As there is a reaction acting here, the force in the members AB and AE are not equals to 0. Similarly, at D also there are two members meeting at different lines. But still there is a reaction RD. So we cannot apply rule number 2. And there is no single member here. So rule number 1 also we cannot apply. Let's see whether we can apply rule 3 or not. So if you see, at E, at C, there are 3 members meeting. So if you consider C, there are 3 members meeting, but all the 3 members are in different lines. So we cannot apply rule number 3 at C. Whereas at E, you can see there are 3 members meeting at a joint at E. Whereas 2 members are in the same line. 2 members are same line. So at joint E we can apply rule number 3. Right? So you can directly write at joint E. At joint E. So whenever you are trying to write about any joint, you have to draw the free body diagram of that joint. So at E there are 3 forces, right? E. Whereas this force will be FAE and this force will be FEF, where this force is FBE, or you can write FEB. FBE or FEB you can write. According to the rule, what do you say? Rule number 3. That is that when there are 3 members meeting at a joint, out of which 2 members are in the same line, then the force in the third member must be 0. So from that rule, we can write directly as FBE equals to 0. FBE equals to 0. Now, we cannot solve the total complete problem using the rules, right? Now, we have to consider each and every joint. Now, how to consider each and every joint? I have told you a simple rule. What is that? Any joint which is having maximum number of 2 unknown forces should be considered while solving. So, let us first see how many members are meeting at particular joint. So, for example, at joint A, how many members are meeting at joint A? 2 members are meeting at joint A. At joint B, there are how many? 4 members meeting at joint B. At C, there are 3 members meeting at joint C. At D, there are again 2 members meeting at joint D. At F, there are 3 members meeting. At E, there are 3 members meeting. Right? So, directly you can see now, A and D are the only joints which are having 2 members meeting. That is, they are having 2 number of unknowns. Right? So, we can consider either the joint A or joint T. There is no rule that you have to start the problem with only joint A. You can consider any joint out of A and D. So now I am considering joint A. I am considering joint A. So whenever I consider a joint, I have to draw the free body diagram, right? So this is A. At A there is a reaction of 14.67 kilonewtons. And there is a horizontal reaction of 20 kilonewtons. And also there is a horizontal member and there is a inclined member. So the force in this member, I'm assuming it to act as away from the joint. Away from the joint. Force FAE and the force in the AB I am assuming to act it towards the joint. Towards the joint. So you can say, do we have to consider the same thing? No, you can either consider FAE to act towards the joint, and you can assume that the force in AB is acting away from the joint also. The beauty of this subject is it will give you the freedom to assume the direction of forces. After the assumption, while solving the problem, if you get the magnitude, you'll get the magnitude and direction in the end, right? So if you get the value as positive, that means that whatever direction you have assumed for that particular force is correct. If you are getting a negative value, the negative sign indicates that the direction you have assumed is wrong. That means in the opposite direction, the direction in which you have assumed, the force will act in the opposite direction to the assumed direction. So if you assume the forces either to act towards the joint or to act away from the joint, it is completely fine. Once you solve the forces, then you have to correct the direction accordingly. And next, we all know that this member is having a theta. Now resolving the forces. AB is an inclined member, so we have to resolve the forces. So this force will have vertical component and horizontal component. The vertical component will be FAB sine theta and the horizontal component will be FAB cos theta. FAB sine theta and FAB cos theta. Now, we can apply two equilibrium equations at any joint. What are those two? Sigma FV equals to 0 and sigma FH equals 0. So, let us apply sigma FV equals to 0. So, if I apply sigma FV, how many vertical forces are there? There are two forces, 14.67 and FAB sine theta. 14.67 kilonewtons is acting upward. So that is positive according to our sign convention, right? Whereas FAB sine theta is acting downwards. Downward force we have considered as negative. Minus FAB sine theta equals to 0. So 14.67 equals to FAB. What is theta here? Sine 38.65. So FAB can be written as 14.67 divided by sine 38.65. If you solve it in your calc, you will get FAB as 23.48 kilonewtons. You got a positive value for the force AB, right? Positive value means the direction of the force which you have assumed is correct. That means the force AB is acting towards the joint. If you get negative, then you have to choose the opposite direction. Then applying sigma FH equals to 0. How many horizontal forces? There are three horizontal forces. One is HA, one is FAB cos theta, and the other one is FAE. According to the sign convention assumed in the starting of the problem, the forces acting towards that side is positive and the forces acting side is negative. So HA and FAB cos theta are acting towards this side. So they have to be negative while writing. Minus 20 minus FAB cos theta, and FAE is acting in the opposite direction. So plus FAE equals to 0. So we can write directly as FAE equals to 20 plus, how much is the FAB we got? 23.48. 23.48 cos 38.65 degrees. And if you solve, you will get this as 38.34 kilonewtons. 38.34 kilonewtons. F force in the AE also we got positive, right? That means the force FAE acting away from the joint. Remember, away from the joint is pulling. Pulling is tension, pushing is compression. Okay, so we have calculated two number of member forces. Now let us go to next joint, that is joint D. Now let us go to next joint D. At joint D we have RD is equals to 15.33 kilonewtons, right? So considering joint D. Considering joint D. So at D, this is D, we are having a vertical reaction of 15.33 kilonewtons, and we are having two members, one is horizontal and one is inclined. So I am assuming that the member force in the horizontal direction is acting away from the joint, that is FDF, whereas the member force in the member CD is acting towards the joint. You can assume the opposite direction also. But if you get positive value, your assumed direction will be correct. And if you get negative value, the actual direction of force will be in the opposite direction of the assumed direction. And we know this is theta, right? And as CD member is a inclined member, we have to derive the components. So the horizontal component will be FCD cos theta, and the vertical component will be FCD sin theta. FCD cos theta and FCD sin theta. Now again same story what we have done for the joint A, applying the forces, that is sigma FV equals to 0. How many vertical forces are there? We are having only two vertical forces. One is upward force and the other one is downward force. Upward force is positive, downward force is negative according to the sign convention I followed in the starting of the problem. So plus 15.33 minus FCD sin theta equals to 0. So directly we can write FCD is equals to 15.33 divided by sin 38.65. If you consider that, you will get FCD equals to 24.54 kilonewtons. 24.54 kilonewtons. Then the other equilibrium equation we can apply here is sigma FH equals to 0. How many horizontal forces are there? There are two. One is FDF and the other one is FCD cos theta. According to my sign convention, FCD cos theta is having positive sign convention and FDF is having negative. So minus FDF plus FCD cos theta equals to 0. So we can write minus FDF equals to minus FCD cos 38.65. So minus minus will get cancelled and FDF can be directly written as FCD you got as 24.54 into cos 38.65. So from this, if you solve it, you will get FDF equals to 19.16 kilonewtons. 19.16 kilonewtons. So we are done with member A and we are done with member B. Sorry. Now with which member can we go? If you see at B there are 4 unknowns, at E there are 3, at F there are 3, at C there are 3. You may say, madam, already at E we have already know that FEB or FBE is 0. So there are only 2 unknowns. We can solve it. Waste of considering joint E. Instead we can consider F so that we can calculate joint force in the member B and force in the member FE also. Now let us consider joint C, because C is having CB member, CF member, CD member, 3 unknowns, but out of which CD is already calculated. Now there are only available unknowns at C are 2. Those are force in the member BC, force in the member CF. So I am now considering joint C. I am now considering joint C. So at C, if you see, there is an inclined member, there is an vertical member, and there is an horizontal member. Where I am assuming, already we know we have got the positive value of CD when we assume the force to act towards the joint. So this is FCD, and also I am considering the force in the member BC also to act towards the joint. When 2 members are acting towards the joint, the other member force should be acting away from the joint. This is FCF, and also we know this is theta. Now we have to resolve the forces FCD. So the vertical component will become FCD sin theta and the horizontal component will be FCD cos theta. So applying the available equilibrium conditions here. What are the available equilibrium conditions? Sigma FV equals to 0. By applying that, how many vertical forces are there? Only 2, right? Upward acting force positive FCD sin theta, downward acting force is FCF, that is negative, minus FCF equals to 0. So already we got FCD as 24.54 into sin 38.65 equals to FCF. Equals to FCF. So FCF when done, it will be equals to 15.32 kilonewtons. 15.32 kilonewtons. Then sigma, the other equation we are having is sigma FH equals to 0. So by applying this, how many horizontal members are there? 2 horizontal forces are acting. One is FBC, it is acting towards that side, that is positive, and FCD cos theta is acting towards this side, that is negative, minus FCD cos theta equals to 0. You can write it as FBC equals to FCD cos theta, that is 24.54 into cos 38.65. So the force in the member BC, when calculated, it will be 19.16 kilonewtons. 19.16 kilonewtons. Till now, how many members we have calculated? We have calculated the force in the member AB, force in the member AE, force in the member CD, force in the member DF, force in the member CB, force in the member CF. Now, joint is it easy to calculate? You can either calculate B joint at P joint or at F joint. So, I am now considering joint F. I am now considering joint F. At joint F, how many members are meeting at joint F? There are 4 members meeting at joint F. So previously I have written here 3, that is wrong. 4 members are meeting at this joint. So if you see, this is the joint F. And now I am assuming the force in the member EF to act away from the joint, force in the member EF to also act away from the joint. Already we have calculated CF force, right? It is also acting away from the joint. FCF. So, the last member BF force should act towards the joint. And from the figure, we can write like this, right? This is theta. This is also theta, right? So, when this is theta, we have to resolve the forces along member BF. So, resolving these two forces, we are having 2 components. The horizontal component will be FBF cos theta and the vertical component will be FBF sin theta. Now, applying the equilibrium equations we have sigma Fv equals to 0. How many vertical forces are there? We are having 2 vertical forces. FCF is acting upward. So, FCF, FBF sin theta is acting downward. So, minus FBF sin theta equals to 0. That implies FCF equals, we know FCF, how much is FCF, right? FCF is equals to 15.32 is equals to FBF sin 38.65. So we can write FBF is equals to 15.32 divided by sin 38.65. From this, if you do the problem, you will get force in the member BF as 24.52 kilonewtons. If you see, we got positive value of FBF, right? That means the direction, the force FBF is acting towards the joint only. If we get negative there, it is acting away from the joint. Now, again, applying sigma FH equals to 0. How many horizontal forces are there? We are having 3. So, forces acting towards this side are, towards my left are negative and towards my right are positive. So, minus FEF, then plus FBF cos theta and plus FDF equals to 0. Right? We know FDF, we know FBF. So, calculate FEF. Minus FEF is equals to minus FBF is 24.52 into cos 38.65 plus FDF is 19.16 kilonewtons. So, minus when cancelled, we will get force in the member FEF as 38.3 kilonewtons. So, now we have calculated all the forces. So, we can end the problem now. No. we have to ascertain the nature of the force and we have to write all the forces of all the members in a tabular form. That will complete your problem. So, see this. Let us just represent the direction of the forces. We know force in the member EB is 0, so there will be no nature. Force in the member AE, we have assumed it away from the joint, so we got positive. So the force in the member AE is acting away from the joint. And the force in the member AB, we have assumed it to act towards the joint. As well, we got positive value. That means force in the member AB is acting towards the joint. Similarly, force in the member BC, we have assumed to act it as towards the joint. And also we got positive. So the force in the member is acting towards the member, towards the joint. Then force in the member EF, we have assumed it to act away from the joint. And the force in the member FD also, we got it as acting away from the joint. Force in the member CD, we got it to act towards the joint. Force in the member CF, we got it to act away from the joint. Force in the member BF, to act towards the joint. So this. Now, write it in a tabular form. First, write what are the available members. So, available members are AB, AE, CD, DF and CF, BC, BF, BE and EF. These are the available number of members, right? So now, what are the forces each and every member we got? We will write it here. So the force in member AB is 23.48 kilonewtons. No need to write if you write there in kilonewtons. Then AE is 38.34. CD is 24.54. DF is 19.16. CF is 15.32. BC is 19.16. BF is 24.52. EB is 0 and EF is 38.3. These are the forces we got. Now we have to write the nature of the forces. Nature means whether the force is tensile or compressive. So what should you remember here? When a force is acting away from the joint, it is called as tensile force. When a force is acting towards the joint, it is called as a compressive force. So AB, in the member AB, it is acting towards the joint. So the nature of the force is compressive. In the member AE, it is acting away from the joint. That means the nature of the force is tensile. Then in the member CD, it is acting towards the joint. So the nature is compressive. Then in the member DF, it is acting away from the joint. So the force is tensile. Then in the member CF, it is acting away from the joint. So again it is tensile. In the member BC, it is acting towards the joint. It is acting towards the joint. So force is compressive in nature. In the member BF, it is acting towards the joint. So again it is compressive. Then in the force BE, the force is only not there in the member BE. It is 0. So there is no nature. You can write nil. Then in the EF, it is again acting away from the joint. So the nature is tensile. If you write the problem, if you solve the problem and if you present all the forces and the nature of forces in a tabular form, it completes your problem. If you do whatever I represent here, if you represent the same thing in the same way in your long answer question, you will get the score very easily. Many people think that problematic subjects are difficult to score, but compared to theory subjects, problematic subjects are very scoring. If you just present in the correct way, that means in a step-by-step procedure, and if you highlight the answers with a box, you will do the problem very correctly and also in a nice representative manner. So this completes one problem. I hope with this problem, whoever has any doubts regarding the method of joins may be solved. So let us see another problem now. So this is the another type of problem. In the previous problem, we have only one inclination of the member, right? Here there are two inclinations, two different inclinations for the members. So the same thing in any truss question, you will be asked only to determine the forces in all the members in a truss when method of joins is used. Now coming to this, the horizontal distances of the members are different as well as the vertical distances 3 meters. And at A, as it is hinged, it will have two reactions. One is RA and the other one is HA. And at D, it is an horizontal roller support. So at D, will have only one reaction, that is RD. So where do we start our problem with? Step 1 is determination of support reactions. So, three equilibrium equations are available. Sigma Fh equals to 0. Is there any horizontal load? There is no horizontal load. So, minus HA equals to 0. The horizontal reaction at A is 0. Similarly, sigma Fv equals to 0. If we apply, it is RA plus RD equals to, I am writing upward forces equals to downward forces. So what are the downward acting forces? We are having three forces. 50 plus 100. So RA plus RD is equals to 200 kilonewtons. Let this equation be 1. So by taking sigma moment at A equals to 0, taking sigma moment at A equals to 0, RD into 3 plus 2, 5, 5 plus 2, 7, 7 plus 3, 10, minus 100 minus 50, 50 is acting in this line, right? 50 into 2 plus 2 plus 3, that is 4 plus 3, 7. 50 into 7 minus 100 into 2 plus 3, 5, minus 50 into 3 equals to 0. From this equation, you will get RD as 100 kilonewtons. And if you apply it in the equation 1, you will get RA, that is 100 kilonewtons. Why did you get both the reactions equal? Because this is a symmetric truss. Because this is a symmetric truss. Now, After this, I told you there are two inclinations, right? Let us see. The member AE is different, having different horizontal length, and the member EG is also having different length. So let the inclination of member AB be theta 1. So this will also be theta 1. And the inclination of BG member be theta 2. So this will also be theta 2. Similarly, as it is a symmetric structure, this will be theta 1, this will be theta 2. This will be, this is theta 2 and this is theta 2. This is theta 1. And this is theta 1. So how to calculate this? Second step is to calculate theta 1 comma theta 2. So from triangle ABE, we can write tan theta 1 is equals to, the vertical distance is 3 and the horizontal distance is 3. So theta 1 equals to, directly we can write 45 degrees. Then from triangle BEG, we can write tan theta 2 is equals to vertical distance 3 by horizontal distance 2. So theta 2 will be equals to 56.30 degrees. 56.30 degrees. These are the two inclinations available. Now, as you have got to know how to calculate this, let me just show you which joint to calculate first. So for that, what we have to do? We have to see how many number of unknowns are there at each and every joint. At joint A, there are two members meeting. So at joint A, there are two unknowns. At joint B, there are 1, 2, 3, 4 members meeting. So at joint B, the number of unknowns are 4. At joint E, there are 3 members meeting. At joint G, there are 1, 2, 3, 4 members meeting. At joint F, 3 members are meeting. At joint C, 4 members. At joint D, 2 members. So if you see, this particular truss is symmetric about this point G. So if you calculate forces in the members on the left side of the truss, directly you can write due to symmetry, and you can write the forces in the members on the right side of the truss. Due to the symmetry, the forces in the left side members will be equal to the forces in the right side members. So you have to start the problem either with joint A or with joint D. After completion of determination of forces in joint AB, member AB and in member AE, no need to go to joint D. As due to symmetry, the member force in AE will be in DF and the force in member AB will be equals to force in CD. So you can directly go to G, because at G you can directly go to B, because after AB you got, directly we know that from the rule 3, force in AB equals to 0. So now only there are two unknowns, right? So if you do the problem, clearly you will understand the concept and you can solve the problem easily. This topic is the most important topic and the easiest topic in the structural analysis, in which you can score maximum number of marks. I hope you have liked today's session and you have cleared your confusions after this session. So if you are having any more doubts, please comment in the comment section, as well as like, subscribe and share the video also. Thank you so much.